Alright, hey guys. So basically, for this session, we are going to have a look at the question, the specific question, which is the second question of our second session that I have been given you guys, or I gave you guys as homeworks. Okay, now let's have a look at the question. This was question number 2. Okay, let's have a look at the question. The question states a velocity time graph. Remember, velocity time graph, meter per second over second. Okay, shows the motion of a leaf. Okay, before we move further on, just remember the logics of a motion of a leaf, which literally means a lift. A lift moves upwards or downwards. That is the logic of the motion of the leaf. That is the case over here. Now, the graph given over here is a VS graph, okay, or VT graph, okay, VT graph. Now, you can see it's going up and then it goes up again here, up and then up again, and then constant, down, constant, up, back to zero. Okay? Now, let's have a look at the question. A. Describe qualitatively. I've mentioned to you guys in the previous session qualitatively, which means one by one. You have to explain whether whatever happens, the motion of the leaf. Okay, it's all about whatever happens. Okay, now you guys can see clearly here it's VT graph, right? So last time we have learned the table. ST graph or displacement time graph relates to VT graph or velocity time graph, relates to acceleration time graph, which is the AT graph. Okay, so you can't be telling me ST graph. Sorry, we have learned this, right? We have learned specifically ST, and then we learn VT, and we learn AT. Displacement time, velocity time, acceleration time. I've said to you, you can go like this, or you can go backwards like this. Now, there's no such thing we are learning like this, okay? One by one, step by step. So over here, we're talking about the VT graph. So there's two ways you can relate. You can relate it to ST or you can relate it to AT. So right now, we are talking about the motion. When we talk about motion, we always target on acceleration, okay? Now, let's have a look at the answers for qualitative motion of the leaf. Number one, I stated you guys have to know which parts to deal with for you guys to explain one by one. So it's quite clear over here that they have already drawn all these lines for you guys. So just follow and go with the flow. This will be number 1, 2, 3, 4, 5, 6, 7, and this will be 1. This also will be 1. Any constant motion also you have to explain. Okay, now let's go one by one. 0 to 5 seconds. 0 to 5 seconds going up like this. Let me use another color. 0 to 5 seconds, the leaf moves upward. Okay, motion of a leaf, upward, downward, very important. You guys can even write positively upward or so on, but it's best to stick on lift. We're talking about lift right now. So the lift move upwards. Why upwards? It's going up right here, positive velocity. From rest, why rest? Because it's 0 over here. With a constant acceleration of 0.4. I stated earlier, when it comes to VT, try to relate to AT. Why? A is a motion. Okay? Of 0.4. How do you get 0.4? I've stated. A, your acceleration is V over T. So you have to take V2 minus V1 over T2 minus T1. Over here, what is your V2? 2 minus 0 over 5 minus 0. You'll get 0.4 meter per second square. That's number one. Number two, 5 to 15. 5 to 15, you can still see an incline or increasing motion of velocity. So the answers will be the velocity of the lift increases, I've stated, increases from 2 meter per second, write the velocity down, to 4 meter per second. But, okay, you have already stated the velocity. You have to say acceleration too. Acceleration decrease. You can't say decelerating. You have to say acceleration decreasing. to 0.2 because initially it was 0.4. Next is 0.2. Why you can't say deceleration? Because it's still in the positive part of it. Okay, you're still moving forward, but just that it's in a slower way. Deceleration is negative acceleration, which means there'll be a negative in front of it. We're talking about acceleration reducing. Okay, now let's move on to 15 to 20 seconds. 15 to 20 seconds, what happened? You can see here constant. It doesn't mean it's at rest. Here, it's not displacement. This is velocity. So when it's velocity 4, which means mula dekat 15 pun 4, 16 saat pun 4, 20 saat pun 4. It stays at 4 meter per second, not 0 meter per second, which means the particle or the lift is actually moving, but at a constant velocity of 4 meter per second. That's the meaning of this graph. Next, 20 to 25 seconds is reducing, right? Ini baru dipanggil decelerates. When the graph goes down like this at a constant rate. Kenapa? Linear. I've stated earlier, if linear, always keep in mind or bear in mind constant, okay, of 0.8 meter per second square. How to get 0.8? Final velocity, tolak initial velocity, divide by 25 minus 20. You'll get 0.8. Okay? Now, okay, can you see a 25 to 30 leaf at rest? Because ini baru kosong meter per second. Baru dia at rest, which means it doesn't move. Okay. Now, let's move on to 30 to 35. 30 to 35, it goes down. Leaf moves downward. Okay. Tadi deceleration, back to initial point. Right now, let's say imagine a leaf is in a building. The leaf is back to 0. Right now, dia move down. Tapi dia accelerate downwards. Tadi tu dari atas dia pergi initial, that's why it's decelerating. Now from 0 it goes to another place, but the only difference is it goes downwards. Itu je beza dia. Tapi dia masih accelerating at what? 0.8. How to calculate? Use the graph same way. Okay, next 35 to 40 here. Ada kan negative 0.4. So constant velocity of 4 meter per second. Now, why can you actually use 4 meter per second or negative 4 meter per second? Because basically, you're still talking about a constant velocity of a particular leaf. That's number one. Number two, it's already down. You're already talking about downward here. So there's no necessity or not necessary for you guys to put negative here. Okay? Next, 40 to 50 second. 40 to 50, walaupun dia balik, tapi kena explain dua benda. Satu, yes, decelerating sebab dia dari bawah nak pergi ke kosong. Anything nak pergi ke kosong atau initial point, decelerating. Tapi kalau from initial point dia pergi mana-mana, is acceleration or moving downwards, moving upwards. Okay? At constant rate, kenapa? Linear graph. And then of 0.4, calculate it through the graph. And comes to rest. Ini jangan lupa. Kenapa? Dia balik sini. Sini sudah kosong. Okay? Alright, that is for A. Now let's move on to how to answer question B. For question B, they state there, sketch a graph of acceleration. See? Velocity always, kalau dia mula dengan motion and so on, right, it will just relate to acceleration against time. Because that is how we learned the relationship. Okay? Tadi, I think in the qualitative part, korang dah belajar. Okay, ini 2 tolak kosong. Oh, korang dah ada jawapan. 2 tolak kosong divide by 5 minus 0. You'll get 0.4. Lepas tu, continue. Here to here. 4 minus 2 divide by 15 minus 5. You'll get 0.2. Macam mana nak connect? Just put a straight line here. Okay? Next, sini. Constant velocity maksudnya ada tak acceleration? Tiada. That's why it's kosong. Ini barulah no acceleration. Okay? Yang ini turun. Same thing over here. You guys calculate 0.8. Here, 0.8. Here, ada tak? Tiada kan? That's why it's no acceleration. Next, here, ada tak? Tak ada kan? That's why it's no acceleration. Next, linear graph over here. You guys know how to calculate. Maintain it up here. Now, jangan lupa balik ke kosong. Sebab sini pun balik ke kosong. Okay? Alright, that is for the graph. The graph will be very easy if you guys know how to describe it qualitatively because the calculations has already been done. Alright, sebab itu soalan untuk A will be more marks than B. Okay, now Let's move on to C. For question C, they ask to determine the total distance. Let me just use another color. Determine the total distance traveled by the lift and its displacement. Sekarang, please remember one thing. Total distance ada tak tolak-tolak? Tiada kan? Tambah je semua. Kenapa? Dia scalar quantity. So when it's scalar and we are talking about distance, tambah, you guys know very well. Kalau nak cari, this is VT graph. Tadi dia cakap apa? Distance. Distance initially you guys know, okay, distance displacement sama je benda. Tapi displacement ada negatif. Itu je beza. So, from a VT graph to find your displacement, what did I say? Kalau lupa macam mana nak cari, just test je. Kalau bagi S, ms negatif 2. Ini akan jadi acceleration. Tapi kalau ms negatif 1 darab dengan S, ms negatif 1 darab dengan S, you'll get M. Adakah ini unit to distance? Exactly. That's why total distance is area under graph of VT. Macam mana nak cari? Cari ni one by one. Triangle, trapezium, trapezium, triangle, trapezium. Okay? Then you get the answer. Tambah. Semua ni tambah je. Tiada tolak-tolak. Okay? Distance. You get total distance 115 meter. Next, let's move on to the second question. Second question, they ask for the displacement. Displacement, nah ini baru tolak-tolak. Kenapa? Sebab dekat sini negative area, sini positive area. Okay? Same thing, displacement area under the graph of VT graph. Area untuk first one, okay? 1 over 2 times 2 times 5. Next, yang ini. 1 over 2 times 2 plus 4 times 10. Kenapa? Formula untuk trapezium 1 over 2 times sum of parallel lines times height. Okay. Next, tambah sini. Triangle. Okay. Next, ini 1 over 2, length dia 5 kan? Tapi height dia negatif. Sebab itu sini, sebenarnya tak payah tulis tolak and break bracket. You can just continue if you know where the negative is. Same thing over here. You guys can just go on with the negative. Okay? You get a displacement of 15 meter. That is for displacement. Alright, last but not least. Let's have a look at the last question. Average acceleration. Average means what? Total kan? From 20 to 40. Dia tak bagi at an instant means, like let's say dia bagi 13 second. Itu maksudnya at a specific time. Yang ini 20 to 40. They give you a range and they ask to find what is the average acceleration within, termasuk atau dalam range tu. Okay. Tulis dulu formula. A average, V2 minus V1 or T2 minus T1. Okay now. A average. Kena tengok balik. V2 tau, bukan V1 minus V2. Okay, macam mana nak cari you punya 20 to 40 second? Velocity, second one minus velocity, the first one. Same thing over here, T2 minus T1. So, negative 4 minus 4. How do you get it? Dekat sini, you kena tengok your T2 dulu. Dekat 40, negative 4. Okay? So, it's negative 4. Dekat V1 atau 20 over here kan? Yes, it's 4. Tapi minus 4. Kenapa? Formula says so. Negative 4, you'll get negative 8 over 40 minus 20 given over here, you'll get 20. So you'll get negative 0.4 meter per second square. Alright guys, I hope you guys enjoy this session and understand whatever's going on over in this question. Okay, thank you very much guys.